Dear students, in the last class we have discussed about that what is the definition of the probability and then what are the axioms of probability. In this class we are going to discuss about the theorems on probability. First theorem. Statement is if S and pi are two mutually exclusive events, then prove that the probability of an impossible event is 0. Here how to prove that? See the proof for this. We know that S is the universal set, that is sample space. Then pi is the impossible event. Then we take that S union pi is S. S is the universal set, pi is the null set. By the set theory, S union pi equal to S. Now, taking the probability on both sides, we will get that probability of S union pi equal to probability of S. By axiom 2, see that right hand side is probability of S. What is by the axiom 2? Probability of S equal to 1. Therefore, we can write this as probability of S union pi 1. But S and pi are mutually exclusive events. Therefore, by axiom 3, what is axiom 3? When A and B are mutually exclusive event, probability of A union B equal to probability of A plus probability of B. Using that axiom, we can write this as probability of S plus probability of pi equal to 1. But the probability of S is 1 plus probability of pi equal to 1. Therefore, probability of pi equal to 0. Hence, true. Theorem 2. A bar is the complementary event of A, then prove that probability of A bar equal to 1 minus probability of A. How to prove this? See the proof. Given that A bar are complementary events. That means A and A bar are disjoint are mutually exclusive events, and then A union A bar equal to yes, sample space yes. Now taking probability on both sides, we get that probability of A union A bar equal to probability of yes. By axiom 2, we get that what is axiom 2 there? Probability of S equal to 1. Therefore, the left hand side will be the right hand side will be the 1. Then what happened to left hand side? Probability of A union A bar. And then here given that A and A bar are mutually exclusive events. Mutually exclusive events. Therefore, by axiom 3, probability of A union A bar equal to probability of A plus probability of A bar. So substitute this in this equation, will get that probability of A bar plus probability of A equal to 1. Then we can write that probability of A bar equal to 1 minus probability of A. So hence proved. Next one is theorem 3, addition law of probability. Addition law of probability. See the statement. A and B are any two events. Then prove that probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. This is the statement. Now we will see how to prove this additional law of probability. Given that A and B are any two events, A and B are any two events, you can see that it is the sample space S. In the sample space S, there are two subsets are there. The two subsets are A and B. A and B here and right there. But I will split into 3 parts. Now you can see the 3 different parts are there. 1, 2, 3. 3 parts are there. Now how can I denote it? You know this part, A intersection B. What about this part? This part. Then this can be written as A minus B. What is meaning by A minus B? The elements in A but not in B. Okay. This also can be written as A intersection B bar. This part can be written as A minus B or A intersection V bar. Similarly, this part can be written as, this particular part can be written as B minus A, or this also can be written as A bar intersection B. First part is A minus B or any A intersection B bar. The second part is A intersection B. The third part is B minus A or A bar intersection B. Now all the three parts are mutually exclusive. Let A intersection B bar, comma, A intersection B and A bar intersection B are mutually exclusive. Now we can find that A union B. See that, take the left hand side, A union B. A union B is the union of three parts, 1, 2, 1, 2, 3. The whole thing is A union B. This thing is A union B. So this A union B can be written as A intersection B bar union A intersection B union A bar intersection B, which is equation number 1. Now taking the probability on both sides, probability of A union B equal to probability of A intersection B bar union A intersection B union A bar intersection B. We know that these three parts are mutually exclusive. So here I mentioned that A intersection B bar, A intersection B and A bar intersection B are mutually exclusive. By axiom 3, we can write that right hand side as, by axiom 3, right hand side becomes probability of A union B equal to, there is no change in left hand side, only change in right hand side, probability of A intersection B bar plus probability of A intersection B plus probability of A bar intersection B. This is equation number 2. We need to find the value of A intersection B bar and A bar intersection B. To find probability of A intersection B bar. How to find the probability of A intersection B bar? Now you can see here A can be, from this diagram we can write that A can be written as A intersection B bar union A intersection B. Taking the probability on both sides. Probability of A equal to probability of A intersection B bar union A intersection B. But A intersection B bar and A intersection B are mutually exclusive. Therefore, probability of A equal to probability of A intersection B bar plus probability of A intersection B. Therefore, probability of A intersection B bar equal to probability of A minus probability of A intersection B. This is equation number 3. To find probability of A bar intersection B. To find the probability of A bar intersection B, take that B can be written as A intersection B union A bar intersection B. But A intersection B and A bar intersection B are mutually exclusive. Therefore, if you are taking the probability on both sides, probability of B equal to probability of A intersection B union A bar intersection B. By axiom 3, we get that probability of B equal to probability of A intersection B plus probability of A bar intersection B. Therefore, this can be written as probability of A bar intersection B equal to probability of B minus probability of A intersection B, which is equation number 4. Substituting 3 and 4 in that equation number 2. Probability of A union B equal to probability of A minus probability of A intersection B bar intersection B plus probability of A intersection B plus probability of B minus probability of A intersection B. Now, this probability of A intersection B get cancelled. The remaining is probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Hence proved the addition of probability. Next one is theorem 4. If A and B are two evens, and B is contained in A or subset of A, then prove that probability of B less than or equal to probability of A. See the proof. Given that B is contained in A, that means B is subset of A. You can consider here this set A. B is contained in A. B is subset of A. Now, this part is A intersection P bar. Now it is clear that B and A intersection B bar are mutually exclusive. B and A intersection B bar are mutually exclusive. A can be written as, see here, A can be written as union of B and A intersection B bar. Taking the probability on both sides, by axiom 3, B and A intersection B bar are mutually exclusive. We can write this as probability of A equal to probability of B plus probability of A intersection B bar. Now, see the relation probability of A equal to probability of B plus probability of A intersection B bar. B is always greater than equal to 0. B is always greater than equal to 0. Therefore, if you omit one term from this side, from the right hand side, then the relation will change as probability of A is greater than or equal to probability of B. For example, one simple example I can write that 4 can be written as 3 plus 1. If you are omitting one value from the right hand side, then the relation will change. Okay, so here, for example, I am writing here 1. Sometimes it is greater than equal to 0. Therefore, simply we can write that 4. If you are omitting one term from the right hand side, the relation will be changed. Okay. Hence, the theorem. Up to now, we have discussed about the theorems on probability. In the next class, we will discuss about the conditional law of probability based on the dependent events.